All right, to start this question off, you'll notice I already plotted the points A, B, and C, D to make that quadrilateral. It's always easier to visualize with problems like these. Now, the first part of the problem is to prove that this quadrilateral is a trapezoid. Now, in order to prove that this is a trapezoid, the strategy we're going to do is pick two pair of opposite sides and prove that they're parallel. And we can do that by comparing their slopes. So obviously, by looking at the quadrilateral that we drew, it looks like AD and BC are going to be parallel. So let's go ahead and prove that. Let's start by calculating the slope of the line AD. And remember, slope is the change in y over the change in x. So the change in y would be the y value of our d coordinate, which is 0, minus the y coordinate of A, which is 6. And then 1, that's our x coordinate of our D point, minus -1, which is the x coordinate of our A point. Okay, working that out, let's see, we get -6 over 2, which is -3. Now let's compare that to the slope of our line BC. Using that same formula, it's going to be -1 minus 8 over 6 minus 3. That's -9 over 3, which indeed is the same slope of -3. Our next step would be to state that AD is parallel to the line BC because their slopes are equal. Therefore, we can conclude that ABCD is a trapezoid because it has a pair of parallel sides. Great. Now let's move on to the second part of the question. What we need to do is prove that ABCD is not an isosceles trapezoid. Oh, and it says that Rayleigh defines an isosceles trapezoid as a trapezoid with congruent diagonals. So that's a nice little hint here that in order to prove that this is not an isosceles trapezoid, we're going to prove the opposite. We're going to prove that the diagonals are not congruent. In other words, they're not the same length. Okay. Now, in order to do that, we're going to be using the distance formula. You'll notice I've already got that written out here. And our diagonals, we've got to make sure we're using the right points here. Our diagonals would be the lines from A to C and B to D. So let's start off with the line AC. The length of that is going to equal the square root of -1 minus 6 squared plus 6 minus -1 squared. Just for the sake of time, I'm going to tell you that that becomes the square root of -8. Next, let's look at the length of the line BD. So to calculate that, it's going to be the square root of 8 minus 0 squared plus 3 minus 1 squared. Working that out, you should get the square root of 68. So clearly, these two diagonals are not the same length. So in conclusion, we can state that ABCD is not an isosceles trapezoid because its diagonals are not congruent. All right, that's all for this question. Hope it was helpful, and thanks for visiting JD's Preparation.